Welcome everyone to this presentation on what's new in GVERSE Geophysics for 2019.4, which is the latest version of GeoGraphix, and it drops in a couple of weeks' time. This is another big update as far as our geophysics capabilities are concerned, with some very interesting and hopefully useful features that I will try and cover today. Here is a summary of everything that is a part of the new release. From our integration workflows to small usability enhancements, this release covers a lot of new functionality, some really good stuff in here. And today I'm going to try and keep it very high level in order to get through everything. But if you have questions or want to learn more about a particular feature, please get in touch either through the questions box here in the webinar interface or shoot me an email. Christina will be sharing my email with you at the end of the session, and I will try to get back to you with answers, explanations, elaborations, whatever you require as soon as possible. The first thing I want to talk about today is our focus on integration with the rest of the GeoGraphix suite. We've always had good data integration between all our various applications, so you can consume data produced in one application very easily in other applications. So for example, data like your log curves and formation peaks are not only easily accessible in geophysics, they are in fact a core part of the overall workflow. Similarly, horizons and faults that you pick in geophysics can be consumed in your geological workflows. Our focus now is to get even better at this integration and do it more at the application level rather than just the data level. So make the whole exchange of data and information seamless, integrate workflows, and essentially enable our users to easily switch their context from a geophysical setting to a geological one, and vice versa. And that's what all these features listed here on this slide attempt to do. As an example, I'm going to switch to GVERSE Geophysics, where I have a map with some horizontal wells displayed on it. And let's say you wanted to analyze the seismic along this particular well. We have a new feature in 2019.4 that lets you open arm lines along the wellbore directly from the map. You can open it along the entire well trajectory or just the horizontal portion of it. You can even add a leading and a trailing distance that's going to extend your arm line beyond the start and end point of your well. So you open an arm line along the wellbore and you're looking at the seismic here. If you wanted to now change this into a geological cross-section, all you need to do is right-click here and say create cross-section in GVERSE Geo Modeling. This will open this up as a geological cross-section with everything configured that you're actually looking at the exact same line with depth converted seismic displayed as a backdrop, which you can of course turn on and off. And we've added the same well, the right color palette, and all other configurations set up on this cross-section. So very easily now you've switched the arm line to a geological cross-section while making sure that the display still looks familiar. Another feature in this release is the ability to track cursors across the two applications. So as I move my mouse on this cross-section, it's tracked on my arm line in the shape of that red cross that's moving around on the top of my arm line. We also track it on the map, so you know exactly where you are in relation to your map as well. As I move my mouse around on the cross-section, it is tracked on the map. And as you would expect, this goes both ways. So if I move my mouse on this arm line, it is tracked along on the cross-section as well. And this applies to all views in both applications. So the cursors are tracked in the sections, the maps, and also the 3D view. We've also extended the support for color palettes that you can define, default color palettes that you can define in your geophysical interpretation. We've extended that support to include our geological apps. So if you have gone in and you've customized your color palettes and the ranges associated with those color palettes to make them do what you want them to do to get your displays to give you the information that you need, you can now access those directly on your seismic backdrop and use those defaults. But you don't have to invoke the entire geophysics interpretation just to change your color palette. If you want to change that view, you can do that from here as well. Just choose a color palette that you want to view it in, but the defaults can now be read directly from the geophysics interpretation. It's very easy now to take an arm line and open it up as a geological cross-section and have it look like you would expect it to look like. Now, another aspect that we've added to this integration is the ability to take your cross-section and open it up as an arm line. So for example, if you want to adjust a horizon or make some fault picks and you want this cross-section that you open right now to be available as an arm line in geophysics, all you need to do now is right-click and say view cross-section in GVERSE Geophysics, choose an interpretation that you want to add it to, and that is going to then show up as an outline. Now, because I sent the same section to Geo Modeling and then back to Geophysics, that's why they show up as two different sections. Two different sections containing the same data, but that could be any cross-section that you have open. It could be a well-to-well cross-section, it could be a buffered cross-section. Whatever you have open in Geo Modeling, when you send it over to Geophysics, it shows up in your interpretation as an outline, which you can then use to adjust your horizons or make your ball picks or whatever workflow you need to be executing. So the communication of sections between Geophysics and Geo Modeling, pretty straightforward now, very seamless. And we attempt to always make sure that the data that you're viewing looks as similar as possible in both applications, so that you don't have to go in and tweak around with the settings to get it to look the way you want it to look. Another key integration feature that we've added is the support for geobodies in Geo Modeling. Any geobody that you've picked on your Seismic can now be displayed on your cross sections and also in the Geo Modeling 3D view. So a geobody is available in all its forms in the Geo Modeling application. So for example, this high amplitude reflector you see down here, I've picked that as a geobody in Geophysics, and to display that here on my cross section, all I need to do is go to Seismic Options, to the Geobodies tab, and all the geobodies that are linked to the interpretation that are available rather in the interpretation linked to this cross section are listed here, and I can choose the ones I want to add, one or more. Click OK, and that geobody is now going to be displayed on your cross section right there. So you can see that this geobody was picked in GVERSE Geophysics, and just like when you access horizons and faults from your seismic interpretation, which is typically in the time domain, the geobody is depth converted on the fly using the velocity model. You can also consume these geobodies in your geological workflows. So this is not just for display only. For example, you can calculate belt statistics for the length of the bore or other production related information in relation to the geobody. I won't go in too much detail about that here. If you're interested in learning more about this particular feature, I encourage you to check out a recent webinar by my friend and colleague Fred Poland on this particular topic. He also covered this in his presentation last week, where he talked about everything that's coming out in our geology applications, which is also a lot of great new features. Both those presentations are available on our website, so please do check them out. So these were the key highlights of the work we've done on integrating our geological and geophysical workflows, with the main focus on the interaction and seamless exchange of data and related information between geomodeling and geophysics. But that's not all we've done. We're always working to improve integration with all applications within the suite. GeoAtlas remains a centerpiece of the entire GeoGraphix system. Ultimately, that's where everything sort of comes together. And keeping that in mind, we've expanded all the ways that you can create layers for your horizons, your faults, your geobodies, and other data to try and make that process more readily available and more accessible. The next thing I'd like to talk about is the improvements to geobody interpretation. Geobodies and geobody interpretation has been an area where we've made significant progress in terms of the workflows we can execute. We introduced geobodies a couple of years ago as three-dimensional interpretation objects that basically represent areas in your data with similar seismic characteristics that you can pick and save and analyze. This release, we're bringing a few more upgrades to how you can detect and work with these geobodies. The first thing looks and is relatively simple, but even though it's a simple change, we believe it will really help our users in picking geobodies off of many more kinds of data. And let me tell you what I mean with an example. So the way we did it before was that I have a section with data from the average energy volume, which is a seismic attribute that I generated and then added back as a version to my interpretation. You can see a big bright spot right here, and to pick it as a geobody, I would just throw some seeds down. And then when I go to generate my geobody, I can define an amplitude threshold, which is basically a minimum and a maximum value that lets me define what samples actually make up this geobody. I hit generate, and it goes through the data, finds connected seeds that fall within this amplitude threshold range, and then gives me the geobody. And this works brilliantly on these kind of data, as you can see here with the body that we just got. Looks pretty good. If I switch this data version back to seismic amplitude, I'm going to hide this as well. You can still see that bright spot on this amplitude volume, but the problem is that the bright spot spans both positive and negative amplitude values. That is not a problem when I'm working with average energy, because that attribute takes the square of the amplitude, so the sign is basically ignored. But with my regular volume, I want to pick this signature as a geobody. I can't really do that using the old method, because that doesn't let me exclude amplitudes. And that is exactly what we've done. You can now exclude amplitudes from the definition of your geobodies. So now, it's going to switch to another geobody. We're going to put some seeds on here on this bright spot that spans both the positive and the negative amplitude values. And when I go to generate this geobody, I can now, from the threshold option, I can choose the outside limits option, then define a negative and a positive cutoff rather, and that is going to then help me generate a geobody that excludes samples that fall within this. So all the high positive amplitudes and all the high negative amplitudes are going to be a part of this geobody. And that's what it is doing now, going through the data, trying to find all the samples that match this criteria, and that gives me this particular geobody. So the inclusion of this simple feature lets me now pick geobodies in areas that I could only previously pick as two separate geobodies. And if I turn them both on, you can see that they're pretty similar. Both of them are pretty similar, but there are differences. And that's where our advanced geobody editing tools come into play. So I have these two geobodies, and I can see that there is some overlap between them, but there are also areas that are part of one geobody which are not part of the other geobody. The new merge function lets me combine the two geobodies into a single geobody. So turn on the merge function, select my two geobodies, right click. Now I can merge them as a union, which will combine the two geobodies such that the final body is a full merger of the two. No areas are excluded. If a sample is a one geobody, it will be part of the merged geobody as well. The second option, merge as intersection, lets me create a geobody that only includes areas of overlap between my two source geobodies. So let's merge this as an intersection. I'm going to call it merger, and I'm going to click OK, and that's going to give me my merged geobody, which you can't really see right now because the other two are getting in the way, so let me hide them. And that's my merged geobody. You can see only areas of overlap that were part of both geobodies show up as a merged geobody. So I get a single geobody that is sourced from the two different geobodies that I picked on two different data. And because I created this geobody as I merged the geobody as an intersection, I get these areas within this geobody which are disconnected from one another, which is typically not what you would get in a geobody if you tracked the signature. But because this was an intersection merge, now this intersected geobody, if you look at it closely, it has areas in it which are disconnected from the rest of the body. Like this piece right here is not really connected to the other geobody. There's this piece here which is possibly not connected to the geobody as well. And that's because you created an intersection, and that includes only areas of overlap. You can continue treating this as a single geobody. So when you create your layers or create your maps, consider all these different parts of the geobody are going to be considered, or you can split it up into the separate geobodies. So all the disconnected parts of the geobody are going to be treated as individual geobodies. To do that, you go to the split option, click split. I'm going to ignore anything that's less than 1,000 samples, so I do not end up with a ton of geobodies that I don't really need, so tiny geobodies that I don't really need. Hit split, and that's going to go through and it's going to find all the disconnected parts of the geobody, which are of course more than 1,000 samples each, and create new geobodies for them, which I can then use individually. So it created 3 new geobodies, ignored about 400 more geobodies, which were less than 1,000 samples. I'm going to save those geobodies to my interpretation. They're going to show up here in the interpretation tree under the geobodies node. That's my 3 geobodies that I just created. I'm going to view them in the same 3D scene, hide this source geobody, the merger geobody, and that's my 3 geobodies that were just created using the split function. So a single geobody, if it has disconnected parts of it, you can split it up into those individual components of the geobody. Additionally, we are also bringing in 3D surface editing. So if there's parts of the geobody that you don't like, for example, you think that this part on this orange geobody should not be here, I just set it as the active geobody, go to the erase function, draw a polygon around the area you want to get rid of, and it is going to then remove that part, that whatever falls within this polygon for the active geobody, so you don't have to worry about this pink geobody getting disturbed because we're only erasing or editing the active geobody, and that way you can then get your geobody to look exactly like the way you want it to look. So that's some of the changes that we've done to improve our manual geobody picking and tracking. But we're also introducing a bulk pick mode, so you don't have to put even down the seeds that you need to look at your geobodies. And I'm going to give you an example of that as well. I have a probe here which is rendered as a volume with transparencies applied, so I can actually see through it and I can see all these different areas. Let me open up the histogram so you can actually see what I mean. So all amplitudes that fall along this green line down here are rendered transparent, so I can see through my volume and I can see these structures. These are not geobodies yet, these are just areas in the seismic that have similar amplitude characteristics. And if I want to pick them all as geobodies and I don't want to put down seeds everywhere, I can use my bulk pick method. Just go to your bulk picker for geobodies. Here you can define your amplitude criteria on multiple versions of the volume. So I can go in here, I can say, okay, I think every average energy value that is greater than a certain value. You can also turn on the amplitude version and say anything that is less than 6500 amplitude or more than 65 plus 6500 amplitude, include that in my geobody. You can control the extents of your area as well, so you can do it for the entire survey. You can do a custom range, so you can give an inline crossline range, or you can limit it to the probe that you have in your scene. So this is probe 1, and this is just using the extents of that probe, using whatever data I have over here. Give it a name, let's just call it bulk. I'm going to switch this off to save some time. Hit bulk pick. Now it's going to go through and it's going to find all these areas in the extents that I've specified which match my criteria, and it's going to automatically create geobodies for them, track them, all the areas that fall within that amplitude threshold that I defined. And if I define multiple, it's going to run this on multiple volumes and end up with geobodies that will that did not require any seeds and were automatically picked for me. And there it is. It took like 15 geobodies that it found. I can close this here and go to my interpretation tree, and these are the bulk geobodies that I found. Right click here, let's view them in the 3D scene to see what they look like. And that's all the geobodies that I found. These geobodies are now interpretation objects derived from the seismic data. Let's hide the probe so you can see a better look, and you can see that these it didn't pick all of this parts in the probe. These little areas are still part of the seismic. That's because it was less than the minimum threshold that we defined, because maybe these are too small to be picked as geobodies for your and that is customizable. You can change it to whatever you need, but this was gone through that probe and picked up all the geobodies and displayed those to me here. Now this the bulk picker can result in unwanted geobodies, especially if you didn't get the minimum size right. You can have tons of geobodies that you don't really need. So we also have brought in interactive tools to help you clean up your data as quickly as possible. We call it interactive delete. Just turn it on, select an area, and that's going to select multiple geobodies for you. Right click, delete selected, and that's going to then very easily delete those 9 geobodies that you selected from your scene. So you can clean up your interpretation if you got unwanted geobodies in it very, very quickly. So those are some of the tools that we've introduced as far as geobody interpretation is concerned, to help you not only pick more geobodies on more kinds of data, but also interact with them more and edit them and split them, combine them, bulk pick them, so that you can get as many of those geobodies as quickly as possible, so that you can use them in your interpretation and your analyses. So let's move on to depth conversion. Some important changes here as well. The first is the ability to add control points for your depth. So if you have some hard data regarding the depth of your horizons, you can now add that either by digitizing it directly on the map or importing an XYZ ASCII file. This file could be coming from your drillers, or could be an isomap layer, any XYZ point file really. And then these control points that you add to your interpretation can now be used in your velocity model and incorporated into your velocity model to fine-tune that model and make it more accurate. On the workflow side, we've made it easier to update the velocity and depth grids for your horizons. This is where you compute velocities or depths along the horizon and then save these as part of your horizon file. Up to now, you've had to do this manually for each horizon. So if you modified your picks or made changes to your velocity model, you had to go in and update all horizons one by one. This is obviously not very efficient, and there's also a higher chance of human error, like forgetting to convert a surface, for instance. So 19.4 gives you a very convenient update all button that cycles through your horizons and does the relevant conversions for you. Now this conversion workflow applies only if you need to save the depth grid as part of your horizon. If you just want to view your horizon in depth, we have what we call a depth view, which takes your entire scene, and this includes your seismic, horizons, faults, geobodies, and everything else. And the depth mode takes all of this and converts it to depth on the fly in real time using the active velocity model. We were limited to viewing the horizons and faults as intersections on the seismic in this depth mode. With the 2019.4 release, you can now view your horizons, faults, and geobodies as surfaces converted using the velocity model. A couple of updates to SynView as well. SynView is our native synthetic editor. This was one of the most popular features from our last release. We have updated it now to model multiples. So if multiples were not completely processed out of your seismic, they obviously don't show up on your log curves. So getting a synthetic to match becomes a little trickier. Not impossible, of course, but you have to take those multiples into account. So we have now added the ability to model the effect of multiples, surface or interbed multiples on your synthetic. We are also introducing a new, more advanced upscaling method for your log curves called Baker's averaging. It's a well-established method for upscaling or blocking, as some people call it, your log curves to get the seismic and log resolution to match more closely. Okay, so some interpretation tools now. These are enhancements to the software that help you directly with your picking and analysis of the subsurface. The first of these that I'm going to show you is straddle slicing. This is where we create proportional slices based on a top and a base horizon. This is a very useful tool employed very commonly in sequence stratigraphy. And let me give you an example. On this section, you can see some horizons picked on what looks like a sequence. I've changed the seismic to grayscale so the horizons stand out a bit more. And if you want to take this package defined by this orange horizon and this green horizon, and you want to slice it up, maybe let's say add 3 horizons that change proportionally as you go from the orange horizon down to the green horizon. So from the horizons menu, go to create straddle slices. Here I'm going to define my top horizon, which is the FS7, and then the bottom one, which is truncation. Change this to 3 and say create, and that's going to go through and it's going to analyze both the horizons, the top and the bottom, and it's going to create 3 proportionally changing horizons that are going to incorporate the information from both the top horizon and the base horizon on how they're displayed. And you can see them popping up on the section in the background, and that's my 3 horizons displayed on that section. And because they're saved as horizons, you can use them in any workflow that you can use a horizon in. So view seismic data on here, or even flatten the section on this one horizon, anything else. And while I have this section open, a couple of other enhancements as far as seismic sections are concerned. So we add these buttons on the sidebar that let you change the vertical and the horizontal scaling on your section. So if you want to stretch the section horizontally, for example, to get a better look at a particular feature, you don't have to fiddle around with the display settings anymore. You can just very quickly change the scale, the traces per inch, horizontally or vertically. So if you want to stretch it out vertically, you can do that using these buttons as well. We've also added a distance on the header. This measures and posts the distance from the first trace of the section on here, and gives you a sense of scale on how big or far apart all of these features are in terms of distance on a map. So small enhancements, but with a potentially big impact on how you interpret your seismic. So that was straddle slicing, and I've gone over these enhancements on the seismic view as well. So let's move on to faults and fault analysis. And the big addition to fault analysis is our steering plot. This complements our rows diagram, where you can take one fault or multiple faults, select them from this list and plot them on this radial axis, giving you the azimuth and the dip of each fault that you select. We've added another chart to it, the standard SteerNet, where you can again plot multiple faults at the same time, or do just a couple of different faults. And we've recreated the tracing paper experience, the classic tracing paper experience, where you can actually take the SteerNet and rotate it around to fully understand where all the stresses are. Staying with faults, we've also made some changes on how you can interpret your faults. So you can see this fault right here, that's an interpolated segment. This is not a picked segment, and you'll be able to see that if I convert this to a surface. So these are picks. The lines with those dots are the picks, the actual fault sticks, and this is the interpolated segment coming from the fault surface that was generated automatically. If you want to modify this, if you want to change this, if you want to convert this to a segment, you don't have to do this manually anymore. Just right click on it and say convert this intersection to a segment, and that's going to add that particular intersection and add it as a segment. And then you can go ahead and you can edit it like a normal fault segment. You can move these nodes around, adjust them, pick them, do whatever editing you need to do on here. We've also added the ability to split your fault segments, and you can do this in the 3D view or the 2D view, where you just right click here, and from the fault segments menu, say you want to split the segment. That's going to take this segment at the point of the right click and convert it into two different segments, which you can then work with independently. So if you want to delete it or unassign it or reassign it to another fault, you can go ahead and do that here very quickly as well. So a couple of useful tools for your fault analyses, including SteerNets, and some changes to the way you can pick your faults. And we've gone over this, so let's move on to Polygon Management. We now have the ability to save and reuse polygons. Any polygon that you draw on the map, you can save. So if you have a polygon around the light traces that you want to use for limiting your horizon interpolations, for example, you just now have to create this complex polygon once, save it, and then whenever you need, you can bring it back to the map. You can even exchange polygons within interpretations and have as many as you need with a helpful little preview to remind you exactly which polygon is what. We also have enhanced how we extract seismic along a wellbore. We used to do this one well, one volume at a time. We have now added support for doing this in batches, where you can select a group of wells using your well-based filters and then extract seismic from multiple volumes all in the same process. You can output the curves directly to GVERSE Geophysics, so save them to the database, the active curve set, or if you need, you can dump them as LAS files to take to other petrophysical analysis software. On the data management side, we've added the ability to change your velocity surveys quickly and more effectively from within geophysics. This is especially useful when you're starting a new project where the wells don't have active velocity surveys. Going in and doing it for each individual well is very time consuming. So now we have a quick method to go in and set the appropriate velocity survey for each well in the project. We can also now edit the headers of the 3DX files without having to reload the 3DX file from Segway data, from small changes like fixing the survey name or the version name to correcting mistakes at the time of loading, like an incorrect sample rate or bad CRS or a bad start time. You can now do all of that even if you don't have access to the original Segways anymore. We've also made several improvements to our Segway Converter. Some of these changes were made part of the 2019.3.1 release, so you may have seen them already, but these include more automated parameter recognition, so reading stuff like start times and line increments directly from the headers, and also UI improvements to make Segway loading a little easier. Finally, we have improved accessibility for our loaders and our interpretation browser by putting them in more obvious spots so they are easier to get to. There are several other smaller enhancements in this release, all designed to make your workflows more efficient. So when you are 3D auto-picking horizons, you can now pick on multiple surveys, run the correlation on multiple surveys at the same time. We have global pick modes that enable seamless switching for views when you're picking horizon and faults both in the 3D view and on your vertical seismic sections at the same time. So the pick mode doesn't change when you switch one view to the other. You can give a different color to your horizontal wellbores on the map. We have multipliers for contour values. It doesn't modify the actual contours, but if you want to display labels in different units or something like that, you can now add a multiplier. We have expanded all distance and area and volume units to include more options. Stuff like miles, kilometers, acres are now available in all calculations. When exporting your Segway, you can choose the version of data you want to export. It doesn't have to be the active version anymore. New horizons created from the calculator can get specific colors assigned. There's a scale bar on the main map. Option to flatten horizons straight from the context menu. And bulk action for faults. So if you want to toggle the display for a bunch of faults or assign the same color to a set of faults, you now have these actions available for multiple faults at the same time. We are always working on improving performance and stability. This release is no different. You find a significant performance improvement in horizon export, up to a couple of orders of magnitude actually. Horizon interpolation is faster by a factor of 3. Polygon editing on the map has been improved as well as the interaction with the fault manager, which is much faster and smoother than it has been in previous releases. So that's a quick overview of what's coming out at 2019.4. We've covered a lot of ground from our integration workflows, depth conversion, tools for Geobody editing, to the simpler stuff like scaling horizontally and vertically on our seismic sections, straddle slicing, polygon management. So a lot of useful features in here, and for our existing users, I hope you'll find these features helpful. For those of you who are not yet using GVERSE Geophysics, I hope you're intrigued enough to give us a try. If you have any questions, comments, or feedback, please do get in touch. Let us know what works, what can be improved, so we can continue to deliver you tools that help you solve problems that you are trying to solve every day you come into work. With that, thank you very much.